Right, so we'll do Thales theorem now. I'll share a whiteboard. Alright, you have to excuse my drawing, it's not very good. But alright, so
Mhm.
why can't I draw a triangle with this? Damn. What? Oh, you can draw. Nice. How did I enable it for you? Acha,
I think
thank you for the
there's
help.
a pin feature now.
There is a what?
There's a feature.
Oh,
Mm.
acha, very nice. Acha, don't make it tough for me, please. NA, hey, kidding. Where is it? अच्छा wait now 1 second थोड़ा टाइम दे दे मुझे why the hell do they not have a triangle here okay and we'll do this let's see the eraser works ah they do not have a
Struggle
tri
is real.
it's very real unbelievable anyway never mind I'll just draw lines okay leave me alone not you
Let me draw.
no wait I'm doing it now little effort थोड़ा तो मेहनत लगता ही है right so this is a triangle let us say a b and c nice all right so this is a triangle abc so basically what is Thales theorem that is basic proportionality theorem bpt so what does it state if there is a line drawn parallel to the sides of the triangle all right so if there is a line which is drawn parallel to one side of the triangle. It could be the base, it could be the other side, anything. All right. Now let's say this line is N and M. All right. So if this N,
Mhm.
provided that NM is uh,
Parallel to BC.
I don't know how to put parallel. Wait, parallel to VC, comma. Then what do you have? The other two sides are
Angle B is
divided.
equal to angle N.
Sorry. Yeah,
Angle B is equal to angle N.
yeah, of course. Angle B is equal to angle V. Do you know why it is equal to angle N?
Because corresponding angles.
Yes, very good. Corresponding angles. So the two are corresponding angles. And one more. What else?
Mm.
Hmm?
That parallel lines have equal angle na, if there is one line. Some
So angle B is equal to angle N and angle C is also equal to angle
angle
M.
C is equal to angle M.
Yes. Also corresponding angles. So that is the first thing. Second thing is if the line is drawn parallel to if NM is drawn parallel to BC, then the line NM cuts both the sides in a fixed proportion. What does that mean? It means simply that AN, alright, the line AN divided by BN is equal to
Is equal to AM is to MC
MC.
divided by
Yes. So why do you have an idea why this is?
that similarity angle.
Not
We can
similarity
also
angle. Sorry, yeah, tell me. Tell me.
angle AMN and angle ABC. We can similar them by taking angle A common and angle B is equal to angle N.
Sorry, can you say that again? Angle?
A will be common for both the triangles.
Alright, so what are you trying to prove in this?
That AN upon BN is equal to AM upon MC.
Alright, so you want to prove it. Alright, so how do we prove that?
by angle axiom.
Alright, so tell me how that is. How does that work?
अच्छा वो there is a theorem na,
Equal
if
angles
two
are.
triangles are there
Hmm.
and they have two angles equal, then they are similar.
E-
Their sides will be in a similar ratio.
yeah, that is true. But so how did you reach there? You tell me. A similarity, yes, but how did you reach there? What? Like, tell me how can you prove they are similar?
Will in triangle AMN and in triangle ABC, angle A is common,
In
and
A,
angle AMN is equal to angle ACB.
angle angle A is common, so you have got one angle. Then what else?
And angle AMN is equal to angle ACB if the lines are parallel.
A AMN is equal to
Angle ACB.
ACB. Why?
Because of corresponding angle.
Very good. How do you know they are corresponding?
Because lines are parallel.
Yes. Very good. No, no, no. I'm just asking to check if you're getting the concept. You don't have to show all this in exam, just for understanding the concept now. Alright, so you've got one side and one angle. Then, sorry, two angles, right? Then done. So, from this, what can we say? A M N. I don't know. Wait. Similar. I'll just put similar to A B C. So, what does this mean? If these two are similar, then
Their sides will be in proportion.
okay. So,
E-
how do I
Similar proportion.
similar proportion? How? Like, tell me if
Uh,
they are similar proportion. Tell me the proportions.
AN upon BN is equal to AM upon MC.
AM upon MC. Very good. Alright. So I think you studied the proof also. Do you want me to go through the proof?
This BPT proof.
Yeah.
Uh,
You want to
please
do this?
tell.
Alright, sure. 1 second. Do you want to take a screenshot or something of this, or shall I clear it off?
No, you're clear. I've taken the notes.
Alright, good. So now let us draw a triangle. What the hell? Sorry, I'm a bit new at this, but at least I know there are tools. When I was teaching Adrika geometry, it was such a headache. I had to take out my whiteboard, and getting the camera angle for that was even more tough. Alright, let's take a triangle.
Use.
Sorry?
Uh,
Yes. Alright, let us draw a triangle. Triangle A, B, C. Alright? So,
mm,
now let us draw a line parallel here. Okay? I don't know if you have this in your book, but what we learned in CBSE 10, this is the proof, alright? N
mm,
M. Let NM be parallel to BC, alright?
mm.
So over here, what we do is Wait 1 second. One second, bro. Sorry.
Why geometry is so tough?
Alright. So let us draw two perpendicular lines, alright? To here. Let us give this the name anything. P, alright? Do you have this proof?
I don't think so. Wait,
Do
let
you
me see.
I'll do it anyway, like it'll help you. It's useful.
A
Okay.
triangle? No, we don't have this.
Alright. Do you want me
Converse
to
of
do you
proportionality theorem.
alright. Do you want me to do this? It's helpful.
You tell.
Alright. And this is one.
What are you proving by this?
Sorry.
What are
They
you
are
proving
proving
by this?
BPT. Alright.
Acha.
So next what do we do? Draw MQ perpendicular to we don't have a perpendicular here. Perpendicular to AN. Alright.
Hmm.
That is the first thing. Then um, what else? NP perpendicular to AM.
AM.
Yes, very good. And what else is perpendicular to what? That's all.
Hmm.
And NC and BM. What are they?
On the diagonals of the trapezium.
Diagonals of what is a trapezium? Right.
Hmm.
This is the trapezium, right? NMBC. They are the diagonals of the trapezium
Yes.
NMBC. Alright? Alright.
Huh.
So now let us first consider triangles. Triangle ANM. Alright? In triangle ANM. Ah, shit. What is its area?
AMN.
ANM. The top triangle. ANM. This one. What is the area of the
Um,
triangle? No, what is the general formula of area of triangle?
Half base into height.
Very good. Half into base
NM
into
into
height.
NP.
Alright, so over here it will be 1 by 2 into what is the base here?
Base NM
No, the base of this
or
triangle
AM. AM.
AN.
AM. AM.
AN. Or AM. You take it as A.
AM.
See, both sides have perpendicular lines, so you can take any one. For the sake of this, we'll take AN. Alright, I'll tell you why in a little while. And what will the height be? If that is the base, then what is the height?
MQ.
Very good. MQ. Alright. This is 1. Like we'll use this later. Alright.
Minus 1 or equation 1.
The equation 1. 1 second, I'll come down. 1 second, sorry. Someone's at the door.
हाँ ये क्या है माँ ये क्या है माँ ये क्या है किसकी दिखा दिखाओ अरे दिखाओ तो
Hello. Sorry for the delay. Right.
हाँ हाँ
So now let us take triangle BNM. Alright. Can you see triangle BNM?
I can see BN.
1 second, bro. I'm really sorry. Jaden, I'm busy and I'm using the laptop. Please don't ask. I'm
66,
busy right now.
55, 58, 65, 72.
72 what?
Marks scored by my mother in high school.
Nice. So area of BNM. Alright. The area is same formula. I won't repeat it again. So what is the this one?
What will be the perpendicular in triangle ABNM?
No, not the perpendicular. What is the base here? BN is the base.
BM.
BN, not BM. BN, right?
Oh, हाँ BN.
Sorry, half into BN
BN.
into 1 second. I'm really sorry. My brother is annoying me. Jaden, I'm busy. I can't call. Yeah, so BN into now the height. So the height over here we have the height over here will be n and this point over here. We can also take that as MQ. Alright? Because they both are of the same values.
MQ is equal to N at that point.
N and this point, yes.
How?
Because I mean the triangle I have drawn here is not very proper. It's not a proper triangle per se, but in such a case where the lines are divided in such a way and two diagonals intersect each other like that, both will form an equal line. You can check it out if you want on your own. Do a rough diagram and you'll see both of them will be of the equal value.
Okay.
Yeah, like over here the triangle isn't what do you say? I've not drawn it properly. It doesn't look like that. But in an actual scenario, that is the case. Alright? Fair enough. So this will be our second equation, right? That's alright?
We will divide both the equation.
Very good, yes. So divide 1 and 2. And 2. What do we get? 1 by 2.
AN upon BN.
1 second. Half into AN into MQ divided by half into BN.
BN
Sorry
into
for the
MQ.
delay. MQ. So by logic, this will cancel out. This will cancel out. MQ and MQ will cancel out. Right? So that will give us. What will it give us?
AN upon BN.
Right. AN upon BN. Remember this as your third one. Alright?
Third.
Right. So now let's move on to another one.
Similarly in triangle.
So again,
Same that
let us take
AM upon MC.
let us again take triangle ANM. Alright? What will its area be? The same thing, but over here, since I want to do for the other side, so always in proof now you will have to manipulate your this one to get it. All right, in proof that sums or in proving something, there will always be a need to have certain manipulations done. So over here, let us see what we can manipulate. So half into what can I change over here? Can I change
AM.
the base and the height? Can I shift it to the other side? It will it the value change though?
Uh,
Because both
no.
triangles can be the base and then the perpendicular line that is there, that will be the height, right? Correct.
Mm,
Are you getting or are you confused? If you're having any doubt, ask me.
no, I'm good.
Half into AM into PN. The only thing I've done from the first one is I've shifted the base and the height, but the values will still be the same, right? Because both of them are perpendicular. And since this is a parallel line, it is cutting both the lines at an exact point. In this diagram, it's not very clear, but in an actual scenario, what happens is this and this are of the same value. All right. And if
Mm,
you know, two lines of a triangle, two sides of a triangle are of the same length, then automatically the diagonals will also be of the same length. Do you agree with that statement?
yes.
Sorry, not diagonals, they're perpendicular points. Will the lines making them cutting them bisecting them at 90 degrees will also be perpendicular. Do you agree with that statement of mine?
Um,
All right, so what I have written here, is that fine? Like any doubts regarding it?
Similarly, we will do this in the triangle
This time we will take triangle,
MNMBC.
not NBC. This time we will take NMC.
No, MNC.
MNC, yeah.
Uh,
And the area of NMC, what will its area be? Half. What is the base over here?
half into MC
Very good. That's the base. And the height?
PN.
Very good. PN. Alright. So this one over here, since my triangle is not very good, I have to apologize for that. That's probably confusing you a bit. But when you are free or something, I want you to take this and try this
Oh,
out. Hello, can you hear me? Hello? Hello? Is my voice
hello,
audible?
are you there? Yeah. Uh,
Hello? Can you hear me?
uh,
Yeah, so I'm saying when you're free or something, I want you to try this out, alright? Draw a triangle similar to this in proper proportions and draw this one. So, and you will find that this line PN will be the perpendicular line, that is the height of NMC. Over here, since my triangle is not done properly, NM is not in this triangle, it is not properly parallel to BC. That's why this trouble arises, while seeing it, it doesn't look like that. But if you try it on your own, you will find out that the case is true. Alright.
mm,
Alright. So this will be our 5, correct? Equation 5. So any idea what do we do next?
again, we will divide this
Or yes, perfect. So what will we divide? 4 on 5 or 5 on 4?
4 upon 5.
Very good. We can divide 5 upon 4. There's nothing wrong with it, but we are trying to prove something over here. So we again, like I said, we'll have to manipulate our answers accordingly. So do you see why proofs are like that? They're a little tricky because even over there that I showed they were that proof that I did in the afternoon for you. You could have taken it any other way, but since they had an RHS which they wanted the LHS to match that RHS, you have to manipulate your answer in many ways. So over here, let us see what happens. All right, into AM into NP, right? And divided by, what do we have here? We have 1 by 2 into
CPN.
MC CPN, sorry, into NP. Again,
NP.
yes, and over here again 1 and 2 will cancel out and P and N will cancel out, right? So what do we get from this? This will be equal to
AM upon MC.
MC. Very good. Alright, so another property, I'm not sure if you're aware. If two triangles share a same base, if two triangles over here, triangles B N M, sorry, let me write that down. V N M and DEC. Alright,
Hmm. Where is DEC?
sorry, not DEC. BNM. What am I typing? Chee. Um, BNM and NMC, right? Now let's prove that this is congruent. Alright? If they are congruent, then they will have the same areas. Would you agree with that?
Uh,
No, do you agree with what I'm saying?
and angle B will be equal to angle C,
Alright, fair enough.
and angle M is equal to angle M.
Angle M is equal to angle N. Alright, very good. Then,
Then what is
instead of that, how about we prove SSS, triple S congruence? Let us see. NNM is equal to NNM, common common side, correct? Would you agree?
uh,
BM is equal to NC. Why are they equal? Dia Opposite diagonals of a
trapezium?
trapezium. Any doubt with this? Now, if you're
This is
having
the
any,
spelling of trapezium.
oh, acha. I'm not sure if this is it, but that's all right. Okay. So two sides are proven. What is the third side left? NB is equal to MC. Why are they equal? Because we already know that MN is parallel to BC. So it cuts both at similar points. Correct?
Hmm.
Now, any doubt? Ask me. No worries. I'll confirm it for you. See, this is not what we are getting from this. We know from before because NM is parallel to BC. Therefore, we knew that AN and AM are equal, right? Because the parallel line, it's cutting both at equal lengths. Similarly, it is cutting these two also.
Hmm.
Yeah, all right.
Hmm.
Therefore, V, sorry, VNM is, I don't know the congruent to NMC. Therefore, what else can I say? VNM, no wait, sorry, area VNM is equal to area of
Is equal to area of
NM.
NMC.
Perfect, yes. Therefore, now shall we divide the areas of both?
We'll get the ratio.
So, since they are equal, alright, can I, you know, let us say, what is the area of this? BNM, what is the
Half
area?
BN into NQ.
Half into,
BN into NQ.
very good, Vn into M, where is Q? Q is equal to half into, what is the area of NMC? MC into, what is the height? We've written it here already, now we can use the same values. Hello, Atharv. Oh man. Oh shit, I hope that's gone, I think. Damn. Anyway, shall we continue? Hello.
I understand.
Yeah, so anyway, so let us just finish it. Alright. So we had realized that the area of those two triangles was equal. Now let us divide them both by, no wait, divide both by A and M. Alright. So what does that give us? We have already calculated both of them. 1 divided by 2 and 4 divided by 5, right?
Hmm.
So AN divided by NB, I think it was, is equal to AM divided by MC.
C.
Yeah. Isn't this what we wanted?
Uh,
For
yes.
hence proved. Done. And just for proper mathematics, we do this. Alright? Yep. Alright, so the meeting is going to end, I think. Not sure how long more we have. Few more minutes, I guess, left. So, what else do you need, Arthur? Do you want the inverse of BPT?
I want to understand internal bisector of an angle of a triangle.
Internal bisector of a triangle of an, sorry, what did you say?
Internal bisector of an angle of a triangle.
Okay, wait one second. Let me check that up. I'm little hazy right now.
Send you the PDF.
No, no, I'm checking it online. I'll just check it once and it's a proof somewhere.
Internal bisector.
Alright,
The
one second.
internal bisector of an angle of a triangle divides the opposite side internally in the ratio of the sides containing the angle.
Alright, can you send me the PDF of that? I'll do it immediately.
I've
Alright.
already sent you.
Alright, cool. I'll end the meeting. You join back, okay? I think our time is running out. Okay?